Hey guys, today's an exciting day because we get to start working with derivative formulas, right? So let's just start with an example of something we know and we should be able to do. So we have this graph f of x equals x, right? And we want to graph out the derivative, and then we're actually going to guess at what the derivative formula is, right? So if we have f of x equals x, we can start by just drawing a point here. And we say, well, at 0, what's the slope here? And notice this thing is linear. The slope is the same everywhere, and the slope here is actually going to be 1. So if I plug in 0, I want to get a slope of 1. So I want f prime of 0 to be 1, since the slope at 0 of f is 1, right? And now similarly, if I look at something like x equals 2, right, what's the slope out here? Well, the slope at 2 is also 1. So that means f prime of 2 is going to be 1, right? And similarly with like f prime of negative 2, that'll also be 1 since the slope here is 1. And so I can graph out what f prime of x actually looks like. You kind of notice that everywhere it's going to have a slope of 1. And so if I had to guess at the equation, I could actually get it, right? So f prime of any number, so the slope of f anywhere, the slope of f anywhere is going to be equal to just simply 1, right? And so if I had this equation, what I'd be able to say is, like, even if I couldn't have seen this graph, if I had this equation, if someone asked me, well, what's f prime of 2? What's the derivative at 2? What's the slope of f at 2? We'd be able to come to this function. We'd say, well, if I plug in 2 here, I'm going to get 1 as an output, right? And so this is part of actually a much bigger rule, and this is called the power rule, right? And so if we have an f of x that's of the form x to the n, and notice that's what we had here, what we really had was x to the power of 1, then the derivative is equal to n times x to the n minus 1. All right, so basically what it's saying is if we wanted the derivative here, we could bring down the 1. We'd have 1 times x, and then to the 1 minus 1 on top, which is equal to 1 times x to the 0, and x to any number to the 0 is equal to 1. So that's just equal to 1. We would have got this number down here. And so you could also write it in this notation here. And now, so I want to show you something cool about this rule before we get some more practice with it. What if I had a graph like f of x, so this is f of x here. What if I had f of x was equal to x squared? All right, so maybe it looks a little bit something like this. All right, and someone wanted me to tell you things about f prime of x. Right? Well, I could use this rule above, right? So if f of x was equal to x squared, so the power rule tells me that if I take the derivative, that f prime of x is equal to, I bring down this 2, and I have x to the 2 minus 1, which is just equal to 2 times x, right? So the derivative, if I wanted to graph out the derivative of this f of x, so the derivative, f prime, is actually just going to look like a line, right? It's actually just going to look like a line. That's really neat. And we could also kind of plug points in, right? So we could know that like f prime of 5, well, that's equal to 2 times 5 is equal to 10, which means that the derivative, the slope at x equals 5 would be 10, right? Equals 10 there. Okay, so just some cool things you can do with the power rule. But let's get some practice with it. What are the types of functions we might see? All right, so we might see something simple, like x to the 5th, right? So in this case, if I take the derivative, all I need to do is I bring down that 5, and I have 5x, and then I do to the 5 minus 1, which is equal to 5x to the 4th, right? Here, I have to do a little bit of work beforehand, because I have to put it into this form, right? So 1 over x, 1 over x to a power, like over here also, is going to be x to that negative power. All right, so this is really to the x to the first power here. And so 1 over x to the first power is just x to the negative first. And so now it's in this form. So if I want to take the derivative, I bring down my n, so negative 1 times x, and then I do n minus 1. So I'll have negative 1 to the x times x to the negative 2, which you could rewrite it like we did at the beginning. X to a negative power is the same as 1 over x to that positive power, so negative 1 over x squared, right? How about if we had something like the cubed root of x? So we need to put it in this form. How do we do that? So this, like if you, sometimes you've probably used this to type this into your calculator, is really x to the 1/3. And so if I take the derivative of x to the 1/3, now that I writing it x to the 1/3 puts it in this form, I can just do n, I can bring down my power, x to the n minus 1. So I get 1/3 x to the negative 2/3 is my derivative, right? Similarly, over here I can do the same thing I did in b. I want to write this as x to the negative 5, and then I can take the derivative because I have put it into this form, and I will get negative 5x to the negative 5 minus 1 is negative 5x to the negative 6, right? This one's already in the form I need, right? It's an x to some power, and so I can just take the derivative right away. I'll get negative 6x to the negative 6 minus 1, which is negative 6x to the negative 7. Now finally, for this last one, I know some of you will know how to do this, but can we put it into this form? Can we put this into this form? And we actually can't. We can't write this as just x to some power. There's always going to be this 3 out here, and we don't know how to deal with this 3 yet. So right now I'm going to say we don't know how to do it. We will know how to do this one later, but for now, I just want you to recognize that we don't actually have the rules to do this. All right. So whenever you're taking derivatives, it's going to match a rule exactly, right? And this doesn't match a rule that we have exactly, so you should not be comfortable doing that derivative yet.